Entonces,
¿qué te es más cómodo?
bien, es la primera vez que estoy haciendo esta sesión. En inglés probablemente era más cómodo, pero lo puedo intentar hacerlo en español.
Ok.
No podemos preguntar a ver si la audiencia...
Sí, a ver qué piensan. A ver, déjame verificar. Si está próximamente. Debería estar streaming en YouTube, pero no sé, no parece que lo esté. Hay alguna cosa que no debo haber hecho bien, yo creo. No sé. Si alguien que está siguiendo por YouTube, si nos podéis confirmar si funciona, porque no funciona.
Pero las personas que están en el chat nos pueden ver
Sí,
ahora.
sí, sí. ¿Se ve en YouTube? Perfecto, pues ya está. Entonces ya está perfecto. Genial. Vale, pues entonces es un tema de la página de YouTube que no refresca bien. Ahora pone en directo, bien. Perfecto. Pues nada. Bueno, pues buenas tardes a todos, o no sé, el momento del tiempo que sea en vuestras localidades. Y hoy tenemos un evento sobre tracing y observability. No sabemos bien qué preferencia tiene la audiencia. If you prefer English o si preferís en español.
Un aviso, mi español es muy mezclado con portugués, entonces...
Si queréis lo podemos dar, no sé, en inglés, y si hay alguien que tiene algún problema con inglés, pues nada, intentamos repetirlo o bueno, la frase se repite o cualquier tema. Si tenéis algún problema con el inglés, por favor, ponedlo en el chat y vemos cómo hacemos. Pues nada, voy a hacer un switch to English. So thank you very much for coming to this meetup about observability, tracing, and let's see what Roberto can talk about tracing, especially in microservices environment. But first of all, what I need to do, as always, is to present the JUG. So let me share my screen. No, here. Share my window. This is the window. Okay. It should be a presentation in the video. If anybody has any problem, please shout us in the chat. So, well, I'm going to present the JUG for those of you that do not know us already. And well, we are the Barcelona Java users group. Okay, and we are a group of people that, well, we are enthusiasts of Java and technologies related, but not only related technologies to Java. We are a non-profit group, and now we are proud to say that we are more than 1,800 members, and we've been working with as a community since 2012, doing several meetups. We try to do twice per month, but it depends on our workload and different things that can affect our cadence. We are also open to discuss new technologies. So if you want to hear about particular technology, or if you want to learn about something, just ping us, and we will try to, or even search the speaker and arrange a meetup. Or if you already want to share your knowledge, we will be more than happy to create this meetup and share with our community. As I said, we meet and discuss about different technologies and frameworks. Do not see us only as a Java group. Obviously, we are the Java user group, but we tend to be as diverse and as open as we can, because we know that in your daily work, you not only use Java, so you use several things, and we will see in a moment which are the technologies that we have covered in the past. If you want to ping us, you have several places to reach us from our main website, BarcelonaJUG.org, but I would say that this is not the most updated one. Meetup.com is the one that we use to publish the meetups, like this one. You can follow us in our Twitter handles, BarcelonaJUG and JVCNConf. Also in Instagram, even in Flickr, we have pictures from past conferences. In YouTube, you can have our recorded sessions from our meetups and also the conference. And the conference that we host every year, JVCNConf, yeah, you can find us there too. So about some of the technologies that we have covered in the past, well, we've covered from Spring, Quarkus, Docker, databases as Neo4j, testing frameworks, Archelian, well, cloud as Amazon Web Services, even TDD as methodologies, Camel, Kubernetes. Well, we've covered lots of things and lots of technologies. About recent past events, well, we had our virtual conference this 2021. We are very happy with the results of the virtual conference. And we also had the physical conference in 2019. We are more than happy about the result. We covered several topics, more than 700 attendees, 3 days, lots of speakers, good food, beach, Barcelona, summer, well, you name it. It was fantastic. And we expect to have the same experience or even better this 2022. Here you can see some of the pictures from the last physical conference that we had. And yeah, we are very proud of the result and all the things that we covered in the conference. And as always, nothing can be possible if there is not a bunch of people, of volunteers working hard, very hard, trying to help the community to grow and to make this event possible. So thank you very much for all the volunteers. Some of the most recent events we've covered, from JReleaser to Project Loom, Quarkus. We did a panel about mobile, in the Mobile World Congress, about the Java present and future. We've covered lots of technologies. Our 2021 conference, well, we had very good results. More than 1,000 people registered, 700 people attended, and yeah, from basically and mainly from Spain, but yeah, 21% in the rest of Europe, and the rest of the world at 10%. So it's very, very amazing, the result. So about the JVCNConf 2022, it will be in July from 18 to 20. And yeah, early bird tickets are already on sale. The call for paper is open, and we accept also sponsorship requests. Please go to jvcnconf.com, and yeah, we hope you can join us. I want to also give a special thanks to Jakarta, because they provide this crowdcast technology to reach you all. And thank you very much for all the events that you have covered in the past and for helping us in this event. And as I said, please join us and contribute as a speaker, reaching us to share a technology, and you want to learn more about that technology. Please reach us, and we will try to make what it is possible in order to make it happen. Here you have our email, and reach us, and yeah, and also in Slack. Please connect to us in Slack, and we can chat about technologies. There are even channels for jobs proposals. And yeah, you can reach the organizers in order to make things happen. And about today's event, well, Roberto Cortez is a principal software engineer at Red Hat, and he's going to talk about tracing, observability, and more related with microservices. And yeah, especially OpenTelemetry, that it is a very trendy thing, very interesting. So I hope you enjoy this event. That's enough of my chat. Let's give the word and the stage to Roberto. Thank you, Roberto.
Gracias, Juan.
Let me stop sharing my screen, and then you can share yours.
Okay. Yeah, so thank you very much for the introduction. Thank you very much to invite me back. It's always a pleasure to present something in the BarcelonaJUG, especially because you're really close to me, well, compared to the rest of the world at least. So yeah, let me share my screen, and let's see. So this is actually the first presentation I'm going to give around OpenTelemetry. I only started to work in OpenTelemetry like a few months ago, maybe like 2 or 3. So that I started really new as well. And well, I think I believe that we were discussing a few things about OpenTelemetry, Jonathan, right? When you were trying to use it, and then we had the idea of making this session.
Totally right.
Are you able to see my screen?
Yes, perfectly.
Okay, wonderful. Yeah, so yes, the topic for this session is I'm tracing you. I've tried to come up with a fun topic for this, and hopefully that's not going to be too many slides. I try to prepare a few demos that I'm going to try to spend more time in, but of course slides are always okay, just to present the topic and for you to have an idea what we're going to talk about here today. Especially if you haven't heard about this before, it's going to be a little bit useful, I believe, at least. Yeah, so agenda for today, yes, we're going to talk a little bit about the state of the art, and how distributed tracing can help us in today's architectures and the applications that we develop every day. We're going to, of course, have a look on how OpenTelemetry gives some of that back to us, and how we can use it either in new applications or even old applications, right? So they do cover some very interesting use cases that I'm going to show as well. And well, we're going to be able to see all of that into some of the demos I prepare for you today. And well, yeah, I mean, probably you heard about microservices before, and maybe a lot of you are using microservices now, right? So you probably were using monoliths before, and well, this for me is the difference between one and the other. I'm not sure if you agree, right? But anyway, coming to this microservices world, which is a very popular architecture these days, is not something that comes completely free, right? You start to have other issues that you usually didn't surface that much when you're using a monolith, right? And if you look into, for instance, what Netflix did, and if you don't know about the history, well, Netflix was one of the first companies that popularizes this type of architectures. They have to build a lot of tooling and libraries to help them out to build this kind of architecture, right? And well, one of the reasons, and when we're talking about this particular problem space on tracing, well, when you have a lot of services going around, it's really hard to understand what's going on, right? So, if everything goes okay, well, you're happy, you're not gonna pay too much attention. But when something goes wrong, then that's when pain starts, and you want to understand what happened, right? So if you start to imagine when we have like all these multiple servers together, right? So of course they add all of these additional complexity, and tracing is only part of that complexity. So we're not going to talk about other complexities that microservices provide. Of course, they came to solve a couple of other issues. So of course, like everything, you have ups and downs, or you have pros and cons, right? But in this particular case, right? So even if you only have two services together, and both of them live in different servers, right? And you have one server that's calling another, right? What something goes wrong between them, right? So who causes it, right? What happened? Was that like a network glitch? Was that like an exception that happened on the server that I called? So who was the causes? What was in the request, right? And when I say request, I don't mean an HTTP request, right? So when I say request, it's just like a general word, right? You can have a request where you're basically requesting something from a queue, right? And that doesn't have to be an HTTP request, just to disambiguate that word a little bit. But anyway, when you have two, right? I mean, things are still manageable. Yeah, you can have like some logs going up, and then you can try to correlate them together. But when you start having 1, 2, 3, 4, 5 services, and all of them are working together and calling each other, then things become very, very quickly out of hand, right? Now, if you go to the Amazon website, or I actually did this screenshot a couple of days ago, and but probably you can find these on any other big popular website like Facebook, Twitter, LinkedIn, well, you name it. But well, I choose Amazon. And basically, I just searched by PlayStation 5. Unfortunately, they don't have them available. But that was not the reason why I searched for that. So maybe this is a little bit small. I'm not sure if you're able to see this properly. But basically, you see all the XML requests that's being done by a simple search and a simple link to a detail page of a product, right? So you see at least, I don't know, maybe 3, 4, 5, 10, I don't know, maybe like 15 requests over here. So these are like images, so we're not going to count them. But basically, some of them seem to be on the same server. Some of them seem to be on different servers. And even if they go to the same server, we don't know what's going to happen when they get there. They might be split into other requests, right? But anyway, we can definitely see how complex it is to load the web page these days with all of these requests going back and forward. And well, I don't know, maybe if one of these requests fail, the web page will load anyway. I have no idea how to try that out. Well, I could, but that's not the point. The point here is you might have an application that does this kind of traffic, and when something goes wrong, well, it may be very, very hard to understand where the problem is, right? Now, maybe you see these, maybe you haven't. I copied this from a presentation that was made from Uber. So as you know, like they're working a lot with Eyyy, which is a tool that allows you to push the tracing data and visualize it, right? And this is actually, I'm not sure if this is still up to date. At least it was like a couple of years ago. But this is a graph that they actually did of their real architecture with microservices, right? So all of these dots represent their internal microservices when they do some kind of request, right? And for instance, those pink arrows that just represent like a call to one service, and everything that happened after you made the first call, right? So you see like that first call. If you see it over here, the first one, well, I don't have any way to point it out. But if you look from the left to right, you see there is like one call from one request with an error, and then you see that arrow just spreads out all over the place, calling like multiple services, and it goes in multiple other paths, right? And those were only the services that would be called, right? And you see there are still a lot of other ones that were not called in that particular request, but they may be called if I change whatever action I'm doing, right? Anyway, you'll see here that it's a little more complex. So if you try to count them up, I don't know, it's probably like 20. So yeah, what will you do if you find an issue in one of these middle calls, right? So how are you going to figure out why the action you were trying to perform failed? How are you going to fix it? Or how are you going to communicate what went wrong, right? So all of that may happen. And remember, and we're going to see that as well, this doesn't need to be synchronous. And when I say synchronous, I'm not talking about sending something to a queue that's going to be handled up asynchronous, right? So, for instance, when you think about, and I'm going to show you an example about that. When you think about a credit card transaction, that may take like a couple of days to complete, right? So it means that your transaction starts in one day and ends in a couple of days later. But you still need to know that that credit card transaction is associated with some kind of action that you perform on your application, right? And that's just a very small example. So when we say synchronous, it means that sometimes actions that you perform on your application may take days to complete, not seconds or not even hours. Okay, so distributed transaction comes to the rescue and tries to help us to figure out some of that problematic, right? So ignore that question mark over there. That was something that I wanted to add, but apparently this slide was not complete yet. But anyway, the idea with distributed transaction is that you're able to track the progress of a particular request. And again, the request doesn't mean an HTTP request, just mean like an action. Probably action is a better word, an action that you perform on a certain system or application or multiple applications, right? And of course, that application or action can generate like multiple events. And those events can spread, right? So they can go to HTTP servers, of course, can go to messaging servers like Kafka, you name it, can go to databases. So when you think about a system, it's not only, and most people usually think on a web application, right? It's not only HTTP traffic. There is composition about a lot of other stuff and a lot of other systems. So while it may seem to be somehow easy to track what's happening in the HTTP world, that's where people are most used to work. You have to remember that our system is not only HTTP. So distributed tracing is also about transversing all the boundaries of your application and actually able to figure out what's happening on the entire system. Now, distributed tracing came up with a couple of concepts, right? So first of all, what we have is we call each of those actions or requests, we call that's a trace, or that's being handed to you by a tracer. And in that trace, you have a couple of other concepts that allow you to collect data and to represent what's happening in each of those steps or each of those events in a way that you're able to interpret, in a way that you're able to see what's happening, right? So for that reason, you have something that we call the span context, and usually that's something that lives for the entire duration of your trace. And again, a trace may live for several days, may live for as long as you want, for as long as the action that you perform on the system lasts, right? Usually it starts with the root span, so that's the span that originated when you do the first action, and then you have all of these compositions where you have a parent span and child spans, right? That's used to represent when you have an action that can perform or spans multiple other events or actions, right? So for instance, if you think about ordering a book, right? And you made the payment of the book. So maybe I have an asynchronous system that's going to generate a couple of actions. So one is going to be do the invoice for that book, and the other one is going to be make an order to dispatch the book to my address, right? So those actions can be completely separate. So meaning that the action that I did to buying the book will generate those two. So meaning that one is a parent and the other two are childs. And of course, there is all these propagation mechanisms that is tied to all of these. So you're able to link all of these together, and then you're able to figure out exactly what happened on that particular one. So this is an example of the buying a book. So these are very simplified. So of course, this is not trying to mimic any particular application. It's just an example that I tried to cave out of my head. So if there are missing steps over here, just ignore them. But the idea over here is I want to buy a book, right? So I pick up the book, so it's not represented over here. It doesn't really matter. But just representing the portion where I'm already put in my payment details. And well, my application will probably process the payment, right? And then I'm probably going to reach out for a payment gateway, and they're going to check my credit card. They're going to lock my credit card amount, right? And once that's done, and I get like confirmation that my credit card is valid and I have the current amount of that the book requires, then probably I can just send like 3 different things. In that particular case, I'm just going to create like a shipping label, right? I'm going to create the invoice to send back to me, and then I'm just going to update the stock, right? And all of these 3, they can be like 3 different systems that are doing this. So meaning that the process payment and the lock credit card, right? Because they are joined together. They have like a parent and child relationship. But after that, when I do the shipping label, the create the invoice, and the update stock, those are like 3 different spans or 3 different actions, and meaning that they're still part of the same trace, but they don't really have a parent trace, because they were just created based on the result of another action that happened in the past. And then maybe here is not really represent, but basically there is no between update stock and ship order, there is like a small gap over there, meaning that maybe a couple of days had passes until someone from the warehouse is going to go and check my order and is going to ship back to me. So in that particular case, you do the shipping order, and when you do the shipping order, that's when the accounting is actually going to deduct my credit card, and then you might have some tracking order that's going to track when the book's going to arrive back to me. And again, all of these. So basically, if you look into this direction, this representation actually makes sense, because you're able to see exactly what happened. You can see the full transaction. You can see which were the actions that executed. You can see the length of the label, or the length of the diagram represents how much time it could have taken, right? And then they represent also the order, right? So then you can have like a concise way. And of course, if one of these things failed, then you know exactly what failed, and you can try to drill back in and see what was the issue, right? But yeah, I mean, all of this is theoretically, or I mean, at least not theoretically, because that's actually implemented. But that was just a theory, right? So the theory and how you can do this is with one thing called OpenTelemetry. So OpenTelemetry is something, if you haven't heard about it, it's something that you can use to accomplish some of those problematic to some of those solutions that I just explained right now, especially with the distributed tracing portions, right? And OpenTelemetry actually didn't came from zero. There were a couple of other projects in the past that maybe you heard about them, maybe you haven't. Those were called OpenTracing and OpenSenses. So both of them were working in the same observability space, and they're trying to solve the exact same problems. Well, I mean, one of them were like mostly focusing on the metric side and logging, OpenTracing mostly on the tracing, but they thought that they were having pretty much the same goals. So both communities on both projects, they came together, and then OpenTelemetry was formed. So now it is more interesting in the sense that a lot of the efforts on this space are being concentrated over here. Now, giving you a little more detail on the OpenTelemetry side, so OpenTelemetry is again a cloud-native project and specification. So you don't have to be scared in the sense that it's like a proprietary thing. So it's completely open source. There is pretty much all the vendors on the observability space are involved in one way or the other. And one of the interesting things about OpenTelemetry is because all these concepts are language agnostic. You can find implementations for all the languages, right? And even though I haven't prepared a demo like that, so I'm just going to use Java. Probably one of the next few demos I'm going to perform, or I'm going to prepare, is actually do the same demo but with different languages or services written in the different languages, right? Because that's what OpenTelemetry is all about. It's not only about the language that you use. So it's something that it should work across all the boundaries, as I mentioned before. And while I gave the examples of databases and GP servers, that also applies to language that you write, because when you're invoking, and sometimes you have to invoke an external service that you have no control about, and so you don't even know in which language that service is being implemented. So that shouldn't be a boundary for you to use OpenTelemetry or to use tracing at all. Now, OpenTelemetry itself actually is not only looking on the tracing side of things, it also looks about metrics and logs. In this presentation, I'm only focusing on tracing, especially because, I mean, metrics and logs are beasts on their own. So I'm pretty sure that's going to be super hard to come up with a presentation where you just talk about all three. Well, you probably could, but it's going to be a very, you're not going to be able to go into much detail. So I think that having just one session per each is probably going to be better. But yeah, for now, I'm just going to focus on the tracing side of things on the OpenTelemetry side. And the idea with OpenTelemetry is that it's able to instrument your application. And when you say instrumentation, it can be either automatic or manual. So you can collect the data from your application or from your services, and then put it in a collector, and then that collector is just going to push that to a tool that is able to interpret whatever data you collected, right? Now, if you look a little bit, so this is actually copied from the OpenTelemetry website, just for reference. And the idea over here is, well, you can have an application, you have the OpenTelemetry library up there. You can even put it as a Java agent. So I'm going to show like multiple ways of how you can use OpenTelemetry, right? So you have to instantiate, or you have to have a no-till collector agent on the side, which is going to collect all the data. And then you can just push that data to a tool like Jaeger or Prometheus or Grafana, whatever you prefer. No, the OpenTelemetry collector doesn't have to be like single. It can have like, or it doesn't have to be multiple. You can have a single one for a lot of services. But the OpenTelemetry collector, it works as a way to abstract the data that's being collected. So it is mostly a vendor-neutral protocol, which uses what they call OTLP, which is OpenTelemetry protocol, to push the data that's being collected to a place where you can actually look at. So that's pretty much the how OpenTelemetry works. So to summarize, is you have the application will collect the data. The data is going to be sent to the collector, and then collector can send it to somewhere else. And again, remember, so because all of these can be asynchronously, and especially every time that you generate telemetry data, that doesn't have to be pushed directly to the collector. So sometimes what's going to happen is all of these data is going to be batches, and it's just going to push it whenever the rules for that kick in. And of course, there are configurations where you can change that. But at least what I'm trying to say over here is that don't expect, well, for the demos I'm going to show, yes, but don't expect to see the telemetry data straight away into the tooling that you have, because it may take some time for that data to reach the tooling. So that's mostly expected to be checked out later and not in real time, so to say. Well, I think I gave a couple of ideas on how OpenTelemetry works and what you should trace, right? But well, you may be asking, what can I actually trace? Well, I mean, virtually everything, right? So you can trace network data, including, of course, HTTP. It can either be HTTP clients or HTTP servers. You can trace databases. You can trace RPC calls, for instance, gRPC endpoints. That's also possible. Messaging queues. You can also trace things like Kafka, even exceptions, right? So you can trace what's happening when an exception comes up. So you can just use your imagination. Now, the interesting thing about OpenTelemetry is that they already implement a lot of that stuff for you. So they give you out-of-the-box way where all of these data is already collected into most of the, or in the most popular libraries out there. So I'm going to show a demo with that. But if you're missing that, maybe the framework that you're using has that, or well, you have to implement your own, or you can just create them manually. But most of the times, what you have out of the box will work pretty okay, or I think very well when you're just starting up. So you just have to check it out and see if that works for you. Yeah, so I did mention this a little bit. So one of the things that the OpenTelemetry project tried to achieve was to have a way for you to start collecting telemetry data straight away without having to change your application or even recompile your application, right? So one of the solutions that I have for that is the Java agent. So the idea is that you just plug in an agent when you're starting up your application with the Java process. So you just have to configure it with a couple of system properties on when you're starting your Java application, and well, you're going to have OpenTelemetry out of the box, which is pretty cool. Now, this is limited to the library supported by the hotel, but if you look into the libraries that they support, well, they already support like maybe like 40 or 50 of the most popular ones. So there's a pretty good chance that whatever application you're using, you're going to see telemetry data being collected. Well, if that particular approach works for you and you're not getting telemetry data, well, you have to check if they support that or not. Well, if they don't, well, you can just create your own, just add an extension for that. It's not really hard to write one. And you can contribute it back, or you can just go to their GitHub repo and ask for a particular support for a particular library. And usually the community is very welcoming, and they really want to help. So there is a good chance that if that makes sense, that's going to be implemented and added to the agent instrumentation later on. Another option is to use library instrumentation, right? So that means that OpenTelemetry is provided by the framework or the library in use. So a couple examples, like Quarkus provides its own OpenTelemetry instrumentation, which also works with agents. So that's also an interesting thing. The idea is that you will use OpenTelemetry API that they provide to implement either library or agent integration. And then if you use both of them, they'll just integrate together, and you have a telemetry data coming from both, right? So Spring also provides their own telemetry integration. So you have to check whatever you have. So as you're probably figuring out, I mean, I wrote some of the OpenTelemetry integration that exists on Quarkus. And so that's why I have to familiarize myself with all of the OpenTelemetry work that's been happening over the last, well, year and a half, I guess. And well, yeah, all of these will be, even being agent or library, all of that's going to be automatically done for you. So for instance, Quarkus does HTTP requests tracing automatically, but that might not be enough. So maybe what you require is you want to create your own traces, you want to add your own information. In this particular case, we call these attributes into the span to collect your own specific information. Well, and that's also possible, right? So what you'll have is you just put in the Java API or whatever language API you're using for OpenTelemetry, and you just access the API, and then you're able to access the current span, the current trace, and add whatever data you want into it, right? So it's not really that complicated, and I'm going to show that as well. Okay, so for the exporting process, right, so I did talk about that a little bit. So I did mention OTLP as well before, which is the OpenTelemetry protocol. So the way the exporter is going to get process, right, and it's going to export all the data that's being collected by the application or the system, right? So we usually go to this collector thing, and then from the collector you can push that to another tool that you're able to visualize what's happening. So probably the most popular tool for that is Eyyy, but other things work as well, like Zipkin or Prometheus. So just pick your own. And yeah, I think that pretty much summarizes the slides at least. So let's try to go do a couple of demos here. I hope that you guys haven't fallen asleep yet. Are we still with me? Because I'm not able to see anything when I'm like full screen.
Estamos aquí siguiendo atentamente, Roberto.
Muy bien. Entonces, vamos a pasar para las demos. Okay, so let me increase this a little bit. Okay, and go to my IDE. Of course, these are like simple demos, but they definitely work with more complex projects. So in this particular case, the first thing I'm going to show is the way that you can actually start straight away with a simple application that you might have. Well, it doesn't have to be simple, but whatever application that you may already have, and how you can plug in the agent to get telemetry data straight away. So this is just a very simple application that I have over here. So it has like a REST endpoint, which generates a number. So I could probably have created like a more complicated one. Well, it doesn't really matter. I'm not exactly sure why that's not IDE is complaining, but I think it should work. Anyway, if you look here in my POM files, see, this is actually using Jetty. So it's deploying Jetty. It has a couple of dependencies over there just to have REST endpoints and CDI. But as you can see over here, there is no OpenTelemetry information in any place. So it's a very vanilla project. So yeah, so I have this project. I want to add OpenTelemetry, and I don't really want to recompile my application, or I don't want to change my application. Well, that's what we're going to do over here. And so the first thing I'm going to do is I'm going to launch a Docker not that one. Just going to launch a Docker compose file that I have over here. Just going to show that in a sec. There you go. But Docker compose file that I have, it's very simple. What you're going to see here is just, sorry, not this one. Okay, there you go. This is a little bit smaller. So this only has Jaeger and the hotel collector, right? So Jaeger is the tool that's going to get the tracing data, and hotel collector is one that's going to collect the tracing data coming from my application. So I'm just going to put this so for us to see what's going to happen on the app. And what I'm going to do now is I'm going to just launch this Jetty. So I'm just going to launch it with Jetty run, like that. Okay, and so let's go to my web browser, and okay, and let's open up here. So can't remember which port Jaeger is running, so it should be this one. There you go. And okay, so should be a little bit better. So I have nothing here yet. And now I'm just going to call, and then the endpoint that I have over here, this basically generates a couple of numbers. So nothing in particular difficult. And now it seems that I have a service here. I go this number API, I do find traces, and now you see that I have some tracing data happening here. So if I expand this, I'll see, well, apparently number API called number generate. This came from the hotel library name Jetty. Tells me the library version. It tells, well, the host is 8080, number generate. That's the REST endpoint that was called. And then what do we have here? Oh, this is JAX-RS endpoint. That's the code, that's the package, or actually the class name where that was called. So you can see that the application doesn't really have any OpenTelemetry information at all, but I was still able to collect stuff, right? Now, how did I do that? So if I go here to the POM file of this one, I actually added here something on the POM file, and that was only to Jetty, right? So as you can see, there is a Java agent which is referencing the OpenTelemetry Java agent jar, and then I'm just basically feeding it some configuration data. And if you can see this configuration data, it just has, well, this is the service name where I want this service to be named, right? And some attributes. So basically, I'm just telling it the version. And then if you go here to Jaeger again, right, you'll see on the tracing portion, let's see, it should be here somewhere. I'm able to find it. Well, you also see like the there you go, the service version, which is 100 snapshot, and the service name is the one that shows up there on the Jaeger UI, right? When I'm searching for something. Yeah, so I did have to change the application, but well, I did change the POM file, but I actually I didn't have to change it. I could just launch it Jetty and pass that in on the command line. I just chose to do it right here just to be a little bit more simple, so I don't have to remember this command or copy it all the time. But as you can see here, I just plug in the Java agent, and then out of the box, I'm collecting telemetry data. Now, the next time I'm going to show, so let me just kill this for a sec. And well, I want to collect some data myself, right? So I'll be a little more simple. I already have this prepared, so I'm just going to shelf this. And the only things that I changed was I added a dependency to the OpenTelemetry extensions annotations, right? And now on my bean, I created this I added this with span annotation, right? So this with span annotation comes from the OpenTelemetry API, and basically what it means is it's going to create a new span on my telemetry information for that request every time I call this method, right? And this method get prefix is being called on this number resource to create the prefix for that number. So if I do a jetty run again, hopefully that should work. And well, let's call a couple of calls here. No, not that yet. Okay, a few of them. And let's go back to Jaeger. Let's do find traces. Now you'll see that I actually have 3 spans, right? And one of those spans is like number get prefix. And now you'll see that I'm collecting data from OpenTelemetry library name annotations, right? And span kind is internal, sure. I haven't really collected any more data. Basically, just collected the that I call these class name or class, well, doesn't contain the full class file name, it's just the simple name plus the method name. But yeah, now I could come over here and I can show you that as well. And use the OpenTelemetry API to collect even more stuff, right? So for instance, you can just come over here and you can say span .current, and you get the current span, right? And then current set attribute, and then you can start setting attributes, and those will be collected over there. So it's very, very simple in that regard. But let's just forget this for now. The thing that I want for you to take from here is you have an application, it's got nothing, you want to add something, you can just plug in the agent, and you'll see the agent is going to start collecting data straight away from you. So even though I don't have any specific things on JAX-RS or Jetty, they already have a Java instrumenter for Jetty and for JAX-RS that's included in that jar, and it's going to collect stuff from you. And that the Java agent jar also has a lot of other stuff for a lot of other libraries. So you're going to see a lot of things getting collected from there. Okay, so that was a very simple case. Now let's close this one. I'm just going to move to this other project, which is a little more, well, not say complicated, but a little more complete. It has a lot of other examples. So let's drop this. Let's stop Docker here. No, just like that. Okay. So now in this other example that I have is pretty much a little bit simple, or not simple in the sense that it's similar with the other one. So I also have a number API. It also generates a number. Now this actually is implemented in Quarkus, but the code is pretty much the same. And the idea here is that I have another microservice. It's a book API, and I want to create the book. And what's going to happen is the book API is going to call the number API to generate the ID, or in this particular case, the ISBN number for the book, and then it's going to store it into a database, right? Now, the first thing I'm going to do over here again is, well, launch Jaeger in a database, right? And I'm just going to launch my book API. So the book API itself, if you look into the code, I don't really have any OpenTelemetry stuff. In this particular case, I'm using the one that's being provided by Quarkus. So it does include the OpenTelemetry library from Quarkus, and it does include, for instance, things like JDBC, right, and the JDBC driver, and these are actually things given to you by the OpenTelemetry Java implementation. So you're able to do telemetry on the database side as well. But everything that you're going to see over here is just automatically collected by the dependencies that you add to your project, if you prefer to do it this way. Now, let's go to localhost 8080, and I have a Swagger UI here, I believe. Yep. And so I'm going to post the book, right? So let's authorize this one. So one important detail about this is, well, you probably remember that I mentioned that when I try to create the book's going to try to call the number API, and this number API is not there anymore. What's going to happen? Well, I'm not sure. Let's try it out. But you remember, I only have the book API running. So let's try this post. And try it out. Okay, execute. And well, apparently it did work. I have like a 201 over here. I have an ESPN which says ESPN fallback. So basically, I actually wrote my microservice in a way that even if the number API is not running, it will still create the book with just like a marker in the ESPN called fallback. And then later on, it will just try to fill that in. Now, let's see what actually happens on the tracing side of things. So if you go here and find tracing, oops, let's do a refresh, okay. And there is the book API over there. Let's do, and you'll see that, well, there's 9 spans. And well, now I exactly know what happened over there. So there are a couple of selects here from the database. You can even see, so yeah, so that's a driver. So probably seeing if there is a connection to the database. And now there is like a fallback handler setting up over there. And now these actually send the book to Kafka. You'll see, well, reactive messaging Kafka over there. So you send that to a topic on Kafka, and that message destination fallback. And then the messaging queue received that over here. And then there is this other call to a fallback SVN that is going to pick what came from the Kafka queue and is going to persist the book with that information. And then you see the select over here, and then you see the update. Right? So that was a little bit complex, right? But you see even though I only show you, I haven't even shown you the code, but just by looking into the tracing information, without even looking at the code, I was already able to at least have some kind of a sense on what happened on that particular call. So if you let's look into a little more detail. So ESPN generated fallback. So as you know, I did mention that these actually sets class names over there. So yeah, I found a class name called ESPN fallback. So now I'll see that I have here a bean that's, well, if there is a fallback, this actually implements a fallback handler. It's going to send the book to a meter. So this is actually backing up with a Kafka queue, right? And if I go here to my tracing again, well, this is actually happening inside Kafka. Let's see if I can, oh, there is this ESPN generator. So let's try to dig that again in the code. Okay, now I see that fallback is happening over here. So now this is interesting because I'm able to just look into the traces and actually try to make a sense of what's written in the code and try to follow the path that happened on that particular request, right? And yeah, so this one over here actually generates the number over here if it's calling the number API client. And well, if it's not, it just generates one over here, which is called this fallback, and then updates the book, right? So this is interesting, right? Now, what I'm going to do next is I'm going to hook up the other service, and let's see if we see a difference, right? Okay, so let's go into Jaeger. Well, not Jaeger again. Let's go here. And let's gonna execute this one again. So I got a 201. Now you see that I didn't got the fallback, so I got like an actual number, and this is actually coming from the number service API. And if let's go to Jaeger, let's do find traces. And what I have here, interesting because I called the same endpoint, which was create, but now you see one has 9 spans, the other one is just 5, right? Because the existence or not of a particular endpoint that's up or not, in this particular case, number API, actually made a completely different stack of calls, and not a stack trace, but basically a completely different path on what happened on my system because number API was not present. But now if you look here, now let's see, okay, so I call books, right? So that was an HTTP call that came from Quarkus, that was on that endpoint, that was a post, that's fine. And then internally, that calls numbers generate, that called the client, right? And now this actually is the one that came from numbers API. So now you can see that what's happening is that OpenTelemetry is being propagated across HTTP, right? You already seen that propagated, but maybe it was not that evident when it was propagated across the Kafka queues in the database on the other trace. But now you see it got propagated to the other endpoint that's living in another service, and well, it called number generate, right? And then it came back, and now, well, I see the insert into my database from that particular book. And if I come here to my Jaeger, now you'll see there's also a number API. And if I find traces for number API, well, it's over there, right? That was the one that it was called as a part of that call. I can definitely call number API manually. So I believe this is actually running on 9080. Maybe not. Let's see. Localhost, 8090. Like that. Okay, so I got one, and if I go here to Jaeger again and we'll find traces, well, now you see that numbers API was just called individually, right? So in this particular case, it was called as part of that trace, and this one just called specifically for that, well, individually or just as a standalone. Now, another thing that I want to show, let's see if I can show this really, it's not really easy. I probably should put some slits in the code to be more easily see. But there is a delay between a fallback and when the message goes to Kafka, right? So when I show you the trace the first time, all the spans were already there. But let me go here, and I'm going to execute this again. And if I come to Jaeger, I'm just going to do find trace, and you see there is like 4 spans on Book API. There's still 4 spans, how I say 7 spans, right? And hopefully we'll get to 9. Well, maybe not. I'll have to see what happened. Oh yeah, so probably that get to 9 because the first call that I did was the database was not ready, so it created like 2 additional spans for the database connections. But let me do that again. But at least I think you saw when it was 4 and then it came to 7. So I'll execute. Yeah. So so there's 4, right? And if I keep refreshing, then there's 7, right? And that for instance is to explain that the traces themselves, they don't have to be happening at the same time, right? So they can take a few seconds to show up, or even a few days to even show up, right? Because what happened is the trace is going to propagate what we call the trace ID into the context, right? And the other service, when it gets the trace ID, well, it knows, well, this is trace that I have to enlist with. And maybe the action for that particular service is going to only happen in 2 hours or even in 2 days, right? But when that is complete, or when whatever or whenever the trace or whatever the span is created for that trace happens, and then it's collected and sent to the exporter, then it's going to end up here associated to the entire action that was performed on that particular call, if that makes sense. So yeah, those were some of the demos that I wanted to show you, right? I think that you have now a rough idea how this works, right? So one of the things that I did over here, and I can also add it, or at this show, I did create like my own an interceptor that traces and creates and adds an attribute, which is the user, and that generated that span. So if I come here to the books, you'll see there is a user attribute, which is called X. Well, probably don't remember when I put X, but that was actually when I authorized here on these OAuth token. And yeah, so as you can see, I can just put my own information on that particular span, and then, of course, see it over there. Now, of course, you have to be a little bit careful. You don't want to overload with this with a lot of information, because there is a cost, right? So you're paying the cost of all the information going back and forward. But there is, of course, a lot of benefit as well if you want to understand what's happening and you want to figure out where you have issues, or even so. You're not only able to figure out issues that happen on the code side, but maybe you can see performance issues, right? Because all of these also records the service time that each span took, right? So, I mean, in here is not really a good example, because I mean, those simple these applications are very small and they're super fast. But you'll see, okay, this step took 38 milliseconds. This one took 4 milliseconds, right? And the entire thing took 23 milliseconds. So you can also use it as a performance measuring to see where you're taking time from whatever action you're performing on the system. And yeah, I think that's pretty much what I wanted to show you today. I think there is some time for questions. So I'm more than happy to take them.
Yeah.
I hope that you enjoy the presentation, and that all of these make sense to you at least.
Yeah, I have to say that, yeah, it was very nice to see all the demos and the slides. And yeah, it may seem a bit complex, but I think that, for instance, the work done in the Quarkus side makes everything very easy in order to, adding annotations, and it's easy to handle at least the tracing. I don't know if anyone wants to do any question. Please ask the question now or not.
Yeah, don't be shy.
I have one question on my side.
Sure.
While people are adding things, is if you don't do anything special, you get all the tracing by default if you have a REST API, and then you will have the tracing from the REST endpoint up to the methods by default. You don't have to do that. You don't have to add anything, right?
For Quarkus, yes.
Exactly. So I was thinking, okay, that's interesting, but what if I want to trace other calls, especially asynchronous calls that are that I want to trace the calls? I see that probably, as you said, now we can overcomplicate things, and we are going to suffer from performances if we add more and more tracing to the system.
Yeah. So on the Quarkus side, that's only we only automatically trace the REST calls when you add the OpenTelemetry extension, right? And you can disable that if you want. right? So, for instance, one way you can look at is well, that doesn't really work if you only have one node. But I mean, we're a microservices world, so we're most likely going to have multiple nodes on all of your stuff. So maybe one interesting thing that we'll be watching and seeing is you can have like a percentage of your nodes with OpenTelemetry on, right? And the other percentage doesn't have that on. So you're not overburdening the entire system, right? So that's a technique that you can use. Another technique is that OpenTelemetry itself does provide what they call a sampler, right? And you can sample the requests based on whatever rules you want to add. So for instance, you can say, I want to sample 10% of the request, right? So that's another option. And in that particular case, what happens is when the request gets to the server, you just have like a very binary rule saying, okay, does it follow on the 10% number? It doesn't. So it just completely shuts down tracing, and you don't have to pay the entire cost, right? And in that particular case, then you can actually have tracing for all the entire nodes, right? So, but there is something that you just have to play with. But yeah, I mean, you can use whatever rule you remember to do sampling. So that's like an advanced feature of OpenTelemetry. You just implement like a class that tells you how do you want to do sampling, and then sampling can obey whatever rule you want. Can be percentage based, can be like endpoint name based, can be whatever rule you can remember. And then it will just tell you if what you're doing has to be traced or not, right? You can even just trace when you have exceptions, for instance.
Yeah.
So
even you can configure everything with properties, right? So it's like, I want to trace now everything, but later on I want to trace small things. I don't touch
OpenTelemetry gives you a lot of fine-tuned details where you can do where you want to enable or disable tracing. So you can even go at the class name level.
Okay.
So kind of like a log, right? Where you just say that you want to log particular appenders on that fully qualified name or log name. And here is pretty much the same. You can say, I want to trace only traces that come to this class name, or I want to trace only trace from this particular library, right? So for instance, all of these, so for instance, database library, the database OpenTelemetry has a name, so it's called the JDBC OpenTelemetry library, and that's like a name. It's kind of like a log name or a logger name. And Quarkus has its own OpenTelemetry name. So you can just say and on the configuration, I want to disable Quarkus telemetry side, or I want to disable the JDBC telemetry side. Right?
Okay.
And you can control. So you can even control vertically or horizontally. It's there is a lot of options in that space.
Okay, thank you very much. We have now a question from Davinia. Hola, Davinia.
Hola.
So she says, if I understood well, the collector is sending the traces to Jagger. Could you please show us this configuration part? Is it possible to write your own collector or process these traces in any way?
Yeah, I mean, you can. There is. So OpenTelemetry provides you its own specification on how to implement that. And it is implemented backing by using the OpenTelemetry protocol. So you can implement your own. So I can share here the screen really quick and show it. So this is actually done. So this Docker Compose file launches Jaeger and launches a service.
Can you? Okay, yeah. Can you make a bigger font?
Yeah. So this Docker Compose files launches Jaeger and launches OpenTelemetry. Oh, sorry, the OpenTelemetry collector, right? And what's going to happen is Quarkus or Jetty, they're going to send the data to this collector, and then the collector is this collector configuration that, for instance, it has like an exporter for Jaeger and tells it, okay, so Jaeger is running over here on this port, so that's where you have to send the data, right? If you want to use Prometheus, then there is like a Prometheus configuration here, right? And you can even have like multiple exporters, right? So you can even export to both Jaeger and Prometheus if you want. But if you want to write your own collector, that's also fine. I don't see. I believe that is not a real. Well, it depends, of course, on the use cases. But I think that what OpenTelemetry provides right now, it's more than enough. So if you feel that something is missing, probably my best recommendation is to just go to the OpenTelemetry collector specification and implementation and just ask them to add it over there or just contribute it there. But usually it works very well with what they give you out of the box.
Okay. So, yeah, if there is no other questions, thank you very much, Roberto, for giving up this presentation. Please, if you can share in the comments the URL for your slides, that would be great. Or I can do it later on if you send me.
Yeah, definitely.
Okay. So I will put them into the.
So they're like, I'm just gonna put them right away. So they're just.
Okay. Also, if you have that code in GitHub, that would be awesome.
Oh yeah, I'll share the GitHub sample as well. So share. Okay, so that's the link. And the GitHub repo for that. It's this one. Okay. So that's the link for the slides and link for the GitHub repo.
Okay. Well, thank you very much, and thank you all for coming. And we hope that we will have you again in any other super interesting meeting as we had today. Thank you very much to all, and I wish you a very pleasant evening, night, morning, or whatever it was. Thank you very much, and hope to see you again soon.
Thank you. Bye-bye.
Bye.